Hey Science 10, this video deals with Blackline Master 10.3a, defining acceleration. And in everyday life we define acceleration as an object that's speeding up, but that's not necessarily true. It could be an object slowing down as well. The term deceleration that we use in everyday sense is simply acceleration. So a better way to think of acceleration is in terms of a rate of change of speed. So whether you're increasing speed or decreasing speed, changing speed is acceleration. And the little equation that we use there, A is equal to delta V over delta T, or very similar to what I did before, average acceleration, AV, is equal to delta V over delta T. So it's just like average speed, I used a little AV there. You could use the same thing with acceleration here as well. So delta V is change in speed, where it's some final speed minus an initial speed. So for example, when you're going from 0 to 100 kilometers per hour, the change in speed would be 100 subtract 0 to get 100 kilometers per hour. And delta T is change in time. If we're talking about like just in school here in the hallway accelerating, we'd most likely be using units of meters per second for speed and time of seconds. And when you have that, you'd end up with meters per second over seconds, or meters per second, which is kind of awkward. So often the 2 seconds are combined together to give meters per second squared. So that's the more frequent way of using units for acceleration. Moving down here, of course, if we're talking about a car, the acceleration of a car or a sports car goes from 0 to 100 kilometers per hour in how many seconds? That acceleration you'd have to leave in terms of kilometers per hour per second, because we can't combine those two units because they aren't the same. So looking at a couple of examples here on the bottom of the page, a motorcycle, for example, in 2 seconds, the speed changes the change in speed is 9.0 meters per second, which means it went from 0 to 9 in that time frame. So working it out there, you can see in your sheet 4.5 meters per second, or simply 4.5 meters per second squared. If we're looking at a car here, change in speed of 100 kilometers per hour, so that means going from 0 to 100, and that happened in 6 seconds. That's fairly quick. So figuring that out, we get 100 kilometers per hour divided by 6 seconds, 17 kilometers per hour per second. So we'd have to state it like that. We can't combine the 2 times because they're not in the same unit. And also what we have with this equation, very similar to the speed equation, average acceleration is equal to change in speed over change in t. We have the return of pyramid power, or the triangle of terror, however you want to call it. Just don't call it lonely. So we have average acceleration is equal to change in speed over change in t. So we have that equation right there, because v divided by t, we have v on top, t on the bottom. If we were looking for time, change in t, if we take a look here, it's v over a. So change in speed over change in average acceleration. So divided by, so that's our second equation. And of course the last equation we could have here, if we're looking for v, using the variables that we have left, a and t, they're side by side on the triangle or pyramid, so that indicates multiply. So the last equation there. So very similar to the change in speed formula, except here we're talking about speeding up, slowing down, etc. Average acceleration.